Hello everyone, in today's video we are going to talk about the decision making in the Chernobyl nuclear power plant accident. That is one of the largest nuclear disasters in human history, if not the largest, happened in the Chernobyl nuclear power plant situated in northern Ukraine. A scheduled late-night test on the 3-year-old reactor number 4 led to the chain reaction which resulted in a series of explosions, a reactor meltdown, and emitting an unimaginable amount of radioactivity material into the atmosphere. The consequences of this event are still being analyzed 29 years afterwards, with the constant fear that the real scope of the accident will never be fully known. The area affected by the radioactive dust and fumes that were released to the atmosphere from the reactor number 4 is estimated to be around 200,000 square kilometers, with most of the European being exposed to high doses of radiation at a certain moment. It was considered the worst nuclear disaster in the history and is one of only 2 nuclear energy disasters rated at 7, the maximum severity level, on the International Nuclear Event Scale. Too many people died due to different fallacies occurred while managing the accident. Understanding how the poor management, systematic neglect of safety issues, concealing of vital information flows in the decision-making process in an overly bureaucratic environment could lead up to catastrophic consequences that are crucial for preventing these events from recurring, especially in the sector of nuclear energy. How can the decisions and actions of the key actors that led up to the Chernobyl accident be explained? And why did these actors choose to take decisions that led to catastrophic event of such scale? The disaster occurred on April 25-26, 1996. When technicians at Reactor Unit 4 attempted a poorly designed experiment. Workers shut down the reactor's power regulating system and its emergency safety systems, and they withdrew most of the control rods from its core while allowing the reactor to continue running at 7% power. These mistakes were compounded by others till the chain reaction in the core went out of control. The subsequent explosion released large amounts of radioactive material into the atmosphere that were carried till the Europe. Everybody makes decisions all the time, whether those are about everyday activities such as what to have for lunch or the bigger ones like what career to pursue. Individuals' decisions are driven by various motives, preferences and thought processes. Sometimes the decisions are made with weighing out different possible outcomes and their consequences by logically reasoning, and sometimes by acting accordingly with the environment, be it the whole society or a narrow collective. It is important to know that decisions individuals make can never be observed just in one way, since it's always a large number of factors involved. There are still unanswered questions that probably will never have the answer, such as why the engineers continue to perform this test even if they had 4 bad outcomes so far, or for example why the government didn't evacuate the population immediately after the accident. In this special event, we found overconfidence of the actors involved, anchoring bias, and conjunctive and disjunctive event bias. The overconfidence effect is a well-established bias in which a person's subjective confidence in his or her judgments is reliably greater than the objective accuracy of those judgments, especially when confidence is relatively high. Overconfidence is one of the examples of miscalibration of subjective probabilities. In this specific case, all the members of the staff were so confident of their ability of coping with the test that they even overrode some basic chemical rules which had much to do with the cooling system, thus making the mistake of overpassing the limits of the reactor capacity by reducing and increasing as a consequence its temperature in a risky way. Indeed, it turned out to be a catastrophe. Relying too heavily on one piece of information in making the decision is what happened in this specific case, where the engineers who were facing with the maintenance of reactor number 4, by trusting too much on the available data, they overrode the limited capability of the cooling system of reactor after the level of the water was lowered so much, provoking the overheating and subsequently the explosion itself. We usually tend to have general bias to overestimate the probability of conjunctive events that must occur in conjunction with one another, and we tend also to underestimate the probability of disjunctive events that occur independently. When multiple events all need to occur, we overestimate the true likelihood of this happening. If only one of many events need to occur, we underestimate the true likelihood of this event. Even in the presence of the likelihood of failure in each component is very low or slight, the probability of an overall failure can be high if many components are involved. Even during the evacuation, several people died, such as firefighters and policemen, because of the level of radioactivity that was so mortal. Firefighters were already aware that going there would have been deadly for them, and they tried to convey some information to the central department in order to send another kind of intervention, such as helicopter and airplane support. But unfortunately, it was denied. The government gave the right and fair choice to leave the city just after 2 days from the accident. Meanwhile, people were going to work normally and people were playing nearby the city. This incident happened because of the overprecision and overconfidence of designers. If they did proper research and highlight flaws in the design, then the situation would never be the same. The accident could have been avoided. But unfortunately, selfishness of people is always present, and even if they use the cheap systems, which cause several deaths and other material losses, This test was tried to do in a very short span of time and without complete research, because people just cared about their promotions and other personal benefits. These findings clearly show that proper management, patience, strong communication, information flow, proper training, transparency, and finally the rational choice-based reasoning are important key in preventing accidents of such scale as Chernobyl. The consequences of this disaster will be around for centuries to come and will continue to remind us how destructive human nature can be if poorly managed.